Hi, and welcome to the next session. I'm Philip. Let me share my screen and we'll jump right into it. So let's go. NoSQL means no security is the topic of this session. And by the way, the question mark at the end is very important. Don't tell me afterwards that I said like there is no security in NoSQL, because that would make my company very unhappy. So just be clear, this is a question mark and we want to dive into the question around that over the next 15 to 20 minutes or whatever we have. So I work for Elastic, the company behind Elasticsearch and various other pieces of software. And I want to give you a bit of a broader picture about the NoSQL ecosystem today. So maybe you don't know dbengines.com. It's a bit like the TIOBA index for programming languages. This one just does the same thing for data stores. And when you look at that, you can see that the relational databases are still very much on top, but you have MongoDB here is the top NoSQL data store in that list. Then you have Elasticsearch, Redis, and recently Cassandra overtook Microsoft Access, which shouldn't be in that list in the first place, but for some reason it is. And I will pick MongoDB, Redis, and Elasticsearch to dive into some security concepts as we go along. So let's jump into it. Everybody knows little Bobby tables, I guess, for SQL injections, and maybe don't call your children like drop table students, or maybe do to figure out if people configured their system correctly and set it up correctly. The nice thing about here or about this in NoSQL is if you don't have SQL, that means you don't have SQL injections, right? Maybe it's not that simple. We'll revisit that topic a couple of times. So let's jump into MongoDB and see what we can do there. Just making fun of MongoDB because everybody does. Now that they're public, you can lose your data and your money with them. Though, admittedly, they have been doing pretty well on the stock market, and also like their consistency models and everything have improved a lot over time. So let's not make fun of that, but let's look at the security aspects. So first off, injections. Maybe you remember the Aspera, the wannabe Facebook killer or whatever from 10 years ago or so, that was initially written in MongoDB. And this is one of the code samples of what they had in there. And this is a classic injection problem. And since they don't have SQL, they do support JavaScript instead. So now you have a JavaScript injection. So here, when you just pass in a query and don't sanitize it and just run a random query, which you shouldn't really do and it's not really a best practice in MongoDB, but you can, then you kind of revisit the same issues that you had in the past. And they have a couple of these functions which are prone to JavaScript injections, like when you run an eval or you run a command in a MapReduce or you just run aware where you can provide JavaScript. Those are all vulnerable to injections. So don't do that if you can avoid it. And you can just disable JavaScript. So if you know that you will never run JavaScript in your data store, just disable the feature and you're done with it. Next up, authentication, which is kind of an interesting topic. So it has been known for quite a long time, and this is German, and I'm sorry for the German, but it basically says that some German university found 40,000 unsecured MongoDB data stores on the internet more than 5 years ago. And it took a while until people came from academia to the real world and figured out a way to make money out of that. But then kind of like the ride was on. So people then found out that you could ransom people for their data. So allegedly you download the data, store it somewhere secure, delete it on the server of whoever owns the data, and just leave a note and say like, hey, if you want to have your data back, please pay here, and we will give you back your data. If they really have a copy of your data and can return it is a different question, but maybe they do. And so this became quite a big sport, which leads us to the questions, or leads us to another example first here, where somebody says like, okay, I found some data that is unsecured. Please give me a contact how we can secure that. And then they ask like, okay, but how did you get our contact details? And they say like, well, that was part of the open data store that we found here. So that leads us to the question, is MongoDB binding to all interfaces, like not just localhost, but all interfaces by default? And no, it is not anymore, though it used to for quite a while. So since 3.6 in 2017, so it took some time from people finding that and then ransoming it. That was disabled for all the binaries that they put out. Though admittedly for the Debian and RPM packages, if I'm not mistaken, that has been disabled for a much longer time. So now every software that they release and every way that they package it, it does only bind to localhost anymore, which is a good first step, which leads us to the second question: is authentication enabled by default? And it is not, which is kind of unfortunate. So you need to enable authentication true or pass the auth flag when you start the binary. And they also have a slightly weird configuration dance when you set it up the first time. So you start the process first without authentication, you add your user, and only then can you log in with that user that you had to create without authentication first. But it is possible. I guess they still don't have that enabled by default, just to keep the bootstrapping problem or the setup as simple as possible, which is especially important in a distributed system. Also, TLS is now included or has been included for quite a long time in pretty much any binary. So this is the good stuff. Just remember, don't run random scripts from users and enable authentication to make your life more secure. Which leads us to Redis then. And Redis has a couple of very interesting points. So first off, injections are totally a thing as well. And they even claim in security that, well, while they don't have JavaScript, they have Lua scripts. That using Lua scripts from an untrustworthy source is a strange use case, and probably many people agree, but it's still something that will happen again and again. Also, Salvatore, the author, whose pseudonym is Antires, he had put out this blog post that eval, the abbreviation of Lua scripts, is a feature that should be on by default. He released that in June of 2018, and I think very soon after that, people found several security issues in that were then fixed, which is slightly ironic, but that's probably what you get when you have scripting in your data store. Coming to authentication, Redis has a bit more of an interesting approach. So a lot of the open Redis instances are infected by whatever kind of malware, also partly probably because Salvatore has a very nice blog post showing how to actually crack an open Redis instance. And in his opinion, he wants to share that because the bad people will figure that out anyway. And he just wants to educate anybody how easy it is to actually break into the server if you have an open Redis instance running. And he goes into quite a lot of detail in his blog as well. Does Redis bind to all interfaces? It does, but with a twist. So what is the twist? They have something called protected mode. So if you run a query locally, it will just run the query and answer that in the default settings. But if you query it remotely, it will just respond with an error and say like, well, remote queries, you need to enable that explicitly either in the configuration or you need to set up security, which probably would make more sense. But by default, it will only answer queries on localhost and give you a proper error message from remote. So they picked this interesting approach of not just binding to localhost, but rather opening up to external interfaces to give you a better error message. And this has been around for quite a while. Security-wise, otherwise, 6.0 came out quite recently, and 6.0 changed a lot in terms of security. So before that version, their documentation claimed a tiny layer of authentication that is optionally turned on is what they provide. And there was no authorization built in. So what you basically got was you had one password that you could use with auth password and then run whatever command you wanted. That password was stored in plain text in the Redis configuration file, and there was no built-in TLS or rate limiting. So you would have to run your own proxy in front to, for example, terminate TLS. And the good or bad thing about Redis is that it's very fast. And since there is no rate limiting, if you can run lots of requests against it, you can also try to brute force passwords very quickly. So pick a very good password here, otherwise that will probably be not helping you out too much. But since 6.0, which came out a bit earlier this year, things have tightened down quite a bit. So now you have access control lists where you can whitelist commands or you can whitelist specific key spaces. And now you have multiple users and you can run authentication for the user with password. Also, while you can still store credentials in plain text in the Redis configuration file, you can alternatively, and it's either this or the other, use or store the SHA-256 hash in an ACL.conf to actually store that. And you can enable TLS in the build now. So Redis also has TLS support built in. So a lot of stuff has improved. One final interesting feature of Redis is that you can hide commands. And that was especially useful before the ACL world, so before 6, when you could disable specific features, what you would do before then is dangerous commands you could just rename. So what that looks like is in the Redis configuration file, you would store this, and to reset or change that, you would need to restart the server. But what you could do is, let's say you want to rename the command config, and you run this rename command with config and then MySecretConfigname. So basically, to run config, you could only access it if you know that it has to be called MySecretConfigname. So basically, you would need to know what did you rename a command to actually be able to use it. And some people used hashing with assault to actually just then use that hash to access commands that they had been hiding before and not explicitly rename it to some other command. What you could also do is you could disable a command entirely by saying rename command config and then give it an empty name. So there is nothing in between the quotations here. So that command would just be disabled and you couldn't access it at all. This was a global configuration and one of the more intriguing security aspects or approaches, I would say. Finally, Elasticsearch. So does it bind to all interfaces? Not anymore for a long time. So we stopped that in 2.0, which came out like, I want to say 6 years ago or 5 years ago or something like that. So it has only been binding to localhost for a long time. Security has become free a year ago or so. Before that, it was one of the paid features, though since Elasticsearch speaks HTTP, you could very easily protect that with an HTTP reverse proxy like Nginx, for example, and also terminate TLS. But a year ago, those features, also because of Kubernetes, became free because there is no easy security model in Kubernetes, for example. Is authentication enabled by default? Not yet. Maybe we can get to that in the next major version. But you can see, since we only added that in 7.1 and not 7.0, it would have been a breaking change. So we didn't enable that by default yet. So 8.0 will be the next chance where we might be able to do that, though that's still a bit off. So we don't really know yet. Scripting is one of the interesting approaches here. If you look at the bad security issues that Elasticsearch had in the past, a lot were related to scripting. Like we relied heavily on Groovy, and then every now and then somebody would find some way to break out of the Groovy sandbox and could then potentially take over Elasticsearch nodes. And we had a lot of the really bad security issues were because of that. So we created our own scripting language, which is called Painless, which might not be the perfect name because people find it pretty painful every now and then. We hired a developer to actually write and create that. It took quite some time to write. And then people often ask, like, why do you even create your own scripting language when there are so many out there? Basically, because we wanted to have two attributes, and those are security and performance. And Painless has been out for a couple of years now, and I'm not really aware of any security issues we had with that. So at least from the security perspective, it worked. And also performance is much better than Groovy because of the way we can store the bytecode. So it was just custom built for this specific use case. And while you don't have to allow list in the first place what you want to have. Okay, and in a later version then, this came out in 5.0 if I remember correctly. In the next major version, the other scripting languages were removed, and since then we don't have any security issues around those anymore, luckily. Ransoming is still an interesting problem, so every now and then you can just look on Shodan for open Elasticsearch data source. So here I look for the default port, which is 9200. Anything that responds with a 200 OK is potentially an Elasticsearch instance like this one here. And if you query one of these instances, then you can just check like which indices or more or less tables are there. And then you might have one that says, for example, please read. And then when you look at that, you will potentially find something like this. And you have this nice message here, which says, well, if you want to have your data back, send 0.5 Bitcoin, or that fluctuated because of the fluctuating price of Bitcoin. So send some whatever Bitcoin here, and we might be able to give you back your data. If all of those instances that you will find today are honeypots, or how many contain real data is a bit up for debate, but open Elasticsearch instances are unfortunately more common than we would want it to be. And yeah, depending on the Bitcoin price, 0.5 might be pretty expensive or not so expensive. And I think at some point when there was this extreme hype around Bitcoin, they would just say like, whatever is $1,000 today, just send us the equivalent in Bitcoin, because if they left a message and 5 days later, the price might have tripled already. So to avoid that, they at some point switched to dollar equivalent, but I think now Bitcoin is a bit more stable again, and maybe they can stick to Bitcoin prices. And finally, sometimes you might run into the so-called Matryoshka problem, or I call it the Matryoshka problem, that somebody takes your data and leaves a message. The data store is still open. So somebody else comes, takes that message and leaves their own message. And to get back to the person that has your data, initially, you would need to go from like one Matryoshka to the next to get back to the original person who has your data, which you probably don't want to do. But yeah. And we ourselves ran some open data stores every now and then. And for example, in Germany, the German CERT would just scan German IP addresses and then send you warning messages through your provider to please fix that, because this is a very insecure setup. And you definitely don't want to have that. And you don't want to rely on the search to be faster to find your open Elasticsearch instances than the bad guys finding them. So just don't run open data stores. So to wrap up, injections are still a thing. And while it doesn't have to be SQL, it could be JavaScript or Lua or Groovy or whatever you have that you don't tighten down. Enable security. Hopefully, the data stores will do that by default, like the relational databases had a bit more time to learn the lesson, and they do that by default now. I hope the NoSQL data stores will get there soon as well. Be creative like Redis, like with the protected mode and disabling or renaming commands, or maybe not. I'm still unsure if that is very creative and interesting, or just like kind of like not the proper solution. So you should find a proper solution, but it's definitely interesting. Custom scripting can make sense in terms of security, especially when you don't want to put various functions like reflection or so on an disallow list or deny list. And security, unfortunately, takes time. So since relational databases had more time to mature, they generally do a bit better than the NoSQL data stores. But the NoSQL data stores are catching up, and I hope we will have like everything like TLS is available, authentication, authorization are available, and they will be enabled by default. I hope that we reach that state soon enough, and that ransomware attacks will become more an uncommon sighting of the past more than a common occurrence, which it is unfortunately still. And with that, let's head to the questions. Thanks so much for listening.